Hello everyone, welcome to Dr. Beena's Forte. Today we are going to discuss a topic in additional mathematics known as functions. Functions is dreaded by many due to its complexity, but I'm here to show you that functions can be pretty simple. Before going on to the main topic, the thing that you need to know about functions would be what is a relation? How do you define a relation? Let me write it here so that we'll have more space later on. Okay? Relation connects two sets, a domain and a codomain. This is a domain and a codomain. There are various other keywords that represents domain and codomain, but it all actually refers to the same thing. Another name for domain would be object. Another name for codomain would be image. And codomain has an extra name here known as range. So this all refers to the same thing. There are four types of relation: one to one, one to many, many to one, and many to many. Alright, example of a one-to-one relationship would be, again, draw two sets, A to B. This shows a one-to-one relationship. One to many. This shows a one-to-many relationship. Got it? One to one, one to many. Let's look at many to one. This is a many to one relationship. And finally, many to many. Can you guess it by now? I hope you guessed it correctly. There. This is many to many. Other than writing a relation in a set form like this, there is another way of writing this domain-codomain notation. We call this ordered pair. So look carefully into this example. Okay, look at this many to one example. How do we write this domain-codomain relationship in an ordered pair form? Okay, we can denote B is related to A, domain and codomain, B to A. So this is your object and this is your image. And the same goes to C, C to A. This is your object, this is your image. Okay. I'm pretty sure that you're familiar with this. What do we call this, everyone? We call this an equation. So how is function related here? An equation can be rewritten in this form. This is an equation, this is a function. So you got the point here. An equation, a function. If you rewrite an equation in a function form, then you call this a function notation. So your domain and codomain, what does it actually represent? Domain is your x values. Codomain is your corresponding y value. Simple? Let's move on. Okay. So now let's get to the gist of the topic. Function. What is function? A function is a special sort of relation whereby one object is only mapped onto one image. Got it? One function mapped onto one object mapped onto one image is known as a function. That's all. Let's come up with an example. Simple. Okay? This is a function. Find f3. What What does this mean? Your x value is now 3. F3 is equivalent to 2, 3 plus 5, which is equivalent to 11. Make sense? Simple. Okay. One more example, probably F4. Let's look at another one more function now. X square minus 2. Find F2. Therefore, F2 is equivalent to 2 square minus 2. The answer is 2. So, this is basic function. This is where you start with the basics. Alright? Okay. Let's draw a diagram to represent function now. Yeah, I hope you got it so far. If you have any questions, you can actually drop me a comment. Okay, let's move on. This is x and your 2x minus 1, 3, 4. 7. 2 times 4, 8. 2 times 3, 6 minus 1 is 5. And 8 minus 1 is 7. So this is how you denote a function. How do you write it down? In plain function notation form. Fx is equal to 2x minus 1. When f is 3, your y, which is this, is 5. And when your x is 4, your y value, which is your 2x minus 1, is equivalent to 7. I hope you got it so far. This is the answer to this. If x is substituted with either one of this value, you will get this answer. So this is how you denote function in a set notation. Clear so far? Good. Let's move on. Next example, which is sketching a graph. How do we sketch a graph for functions? Okay, let's start with an example. Okay, question is, sketch a graph for the function fx is equivalent to 2x plus 2 for this particular x values. Okay. What does this mean? What can you see that these two straight lines here? These two straight lines here represent an absolute value. We call this an absolute mode. What does this mean? What does absolute mean? Well, this sounds a little weird. This means that the value of this particular function should always remain positive. Meaning that if you substitute, say for example, you substitute a certain x value here, which gives this answer, which gives a negative answer. Therefore, you will have to change it into a positive value. Okay, so let's not delay further and move on to sketching this graph. Alright, so have a look at it properly. Sketch. This is not plotting, this is sketching, which means that chances are that you will not need to use a graph paper, more or less an estimate value. And after that, after sketching this graph, you will be required to find the range for this F domain. How does this work? Let's look at method 1. There are two methods to solve this. Okay, two methods. Okay, the first method is, obviously if you want to sketch a graph, you will have to have this table x and fx. So what are the x values that is required? You can see here, it's -2 right up to 2. -2, -1, 0, 1 and 2. What are the corresponding fx value? I hope you're with me right now. -2 times 2 is -4. -4 plus 2 is -2. Next, -1. -2 times -1 is -2. -2 plus 2 is 0. 2 times 0, now x is 0, huh? 2 times 0 is 0. 0 plus 2 is 2. 2 times 1 is 2. 2 plus 2 is 4. 2 times 2 is 4. 4 plus 2 is 6. Shall we sketch the graph? Okay. Again, sketching is all about estimating your coordinate plot. But make sure your estimate is logical. Hopefully, you have to make sure that your graph doesn't look funny in that sense. Okay, so this is fx and this is x. X, -2, -1, 0, 1, 2. This is the given x range. Fx, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay, -2, -2, -1, 0, 0, 2, 1, 4, 2, 6. Sketch this straight line. Beautiful, right? Okay. Remember mentioning, I've mentioned about this absolute value. So what can you see here? You can see that our fx here is a negative value. So if you want to sketch a graph like this, always remember that the ranges should be above, should be on the positive region. So the first method in modifying this graph is that all you have to do is, can you see this intersection point here? -1 and 0, it intersects at the x-axis. All you have to do is just come up with a mirror image of this particular line above. Okay, so here you will get something like this, -2 and 2. You have reflected this portion of the graph above, an exact mirror image. So your new coordinate here would be -2 and 2. This is 2. So this is your coordinate. Got it? -2, 2. You have just reflected again, you have just reflected this particular portion of the graph above. So therefore, this is a modulus graph. Okay, before solving for this portion of the question, let's go on to method 2 first. Okay, so what is method 2? Method 2, very simple. Instead of coming up with a negative value in the table and then doing this mirror image stuff, all you have to do is, in this particular table itself, change all the values to a positive one, to a positive value, which means that in this fx values, the only value that is negative is this. So we change this to a positive value, and so that you can immediately sketch the graph as it is. So now we have sketched this graph. Let's go on to the second portion of the question. Find the range for this f domain. Okay, what does this mean? Range for this f domain. Okay, the range for this f domain is simply the region that has been covered by the graph. What does this mean? Can you see that this graph covers from the origin of the x-axis right up to 6? For this f domain refers to the y-axis. find the range for this F domain, meaning that they want you to find the range for the y-axis. And the graph covers the y-axis from this point right up to 6. Therefore, your answer should be fx larger than or equals to 0, lesser than 6. Got it? You've nailed the question beautifully. Clear? Let's move on to the next subtopic of function. We call this composite function. Okay? I would personally name it function inside function. Say for instance, you are given two functions. Fx is equivalent to 2x plus 5. Gx is equivalent to 3x plus 7. Find f g x. How do you do this? Okay, very easy. The first step is f. Can you see that there are two functions combined in one? This is called a composite function, combination function. Place a square bracket here. Why a square bracket? Because you can clearly see that this is made up of two functions and the function of f has a new x value, and this x value is actually gx. Okay, may sound a little complicating, but just hang on with me. You'll be able to master this beautifully. Okay, so now, according to the square bracket, f square bracket gx. F gx is, just rewrite this back again. Does this notation make sense to you right now? The function of f has an x value of 3x plus 7. Okay, so if we want to rewrite this notation, what happens? Okay, fx or f3x plus 7 is equivalent to, okay, take a look here. This is function f 2. I'm rewriting 2 back again. My x value is 3x plus 7. So I substitute this x with 3x plus 7. 2, 3x plus 7 plus 5. 6x plus 14 plus 5. You get 6x plus 90. Easy, right? One more example. Find g f x. Continuation from this question. First step again. G, place a square bracket. So, for all that you know right now, the function of g has an x value of this 2x plus 5. Rewrite it back again. Now, this is function gx. Now, always remember, this represents the main function, and this square bracket portion is your x value. Therefore, 3, what is fx? 2x plus 7. This is, I'm substituting x with this value. 3, 2x plus 5, sorry, plus 7. 6x plus 15 plus 7, 6x plus 22. That is gfx. Another one more composite function example. Hope it's going good so far. Let's look at another example. G square x. how do you find the answer for this? G, G, X. You have to rewrite this into this, G, G, X. Next step would be placing a square bracket. Okay, so the function of G has an X value of 3x plus 7. Okay, so again, function of G is 3x plus 7. I'm substituting my x with gx, which is 3x plus 7 plus 7. Where did this plus 7 come from? This is the common question that I get from students. Remember, function gx is actually 3x plus 7. What I'm trying to do is I'm just substituting the x with 3x plus 7. So naturally, you are just rewriting this equation. You're just substituting this x value with 3x plus 7. So this should be copied down naturally. Just follow this step, but follow the order of completing this question. So 9x plus 21 plus 7. One common mistake that I see students do is that they solve two questions, they got it correct, and then they feel overconfident. The next thing you know is that the following questions you make a careless mistake. Alright, at maths it's all about practice, practice and more practice. So make sure you follow the order of solving the question properly so that you can avoid careless mistakes. Okay, so yeah, this is composite function. Clear? Now let's go to another subtopic, which is also the final subtopic for this chapter, known as inverse function. Okay, what does inverse function mean? Reversing a function. Let's just stick with the same example since we've already written this down. Fx is equivalent to 2x plus 5. Okay, fx is equivalent to 2x plus 5. Before that, how do you write inverse function? How do you represent inverse function? Inverse function is always represented by a negative 1 on top. Okay, it has a power of negative 1. You know, okay, so same thing. If you see this notation, immediately you should recognize that this is an inverse function. Okay, follow step by step. It is advisable for you to not miss any steps. Even you're super confident with your answer, do not do it. Okay, fx is equivalent to 2x plus 5. Okay, let fx equals to y. Got it? Next, y is equivalent to 2x plus 5. Now, make x the subject. Make x the subject. 2x plus 5 is equivalent to y. 2x is equivalent to y minus 5. X is equivalent to y minus 5 over 2. You've made x the subject already. Final step is to change this equation, change this particular value here back into x, which means that you write this as an inverse function equals to x minus 5 over 2. X minus 5 over 2. The same notation. I have to change it back to an x, right? Because I'm not finding the function of y, but I'm finding the function of inverse function of x. Therefore, we didn't write the question in case you're confused. Find f negative 1x. There, got it. So F inverse is actually x minus 5 over 2. I have just changed this alphabet back again to x. Clear? Let's try one last example using this value. Remember this equation because I'm going to rub this off. Gx is equivalent to 3x plus 7. Okay, gx is equivalent to 3x plus 7. Another one more inverse function example. And we will be able to master this chapter. Gx is equivalent to 3x plus 7. Find g inverse. Follow the step back again. Let gx is equivalent to y. Y is equivalent to 3x plus 7. Make x the subject. 3x plus 7 is equivalent to y. 3x is equivalent to y minus 7. X is equivalent to y minus 7 over 3. Then all you have to do is just change this y back into x. Therefore, your g inverse would be x minus 7 over 3. You got the answer. I hope you found this video useful. Please do subscribe to my channel and my website. The link is written below in the description. And I will see you again in the next video. Thank you.